Hi, it's Mrs. Seitz, and today we're going to be learning in Lesson 6.5 some special properties about trapezoids and kites. A trapezoid is a quadrilateral with exactly one pair of parallel sides. The parallel sides are called what we have in this picture here, the bases. A trapezoid has two pair of base angles. For instance, in trapezoid ABCD, angle D and angle C are one pair of base angles, and another pair of base angles that we would have would be angle A and angle B. The non-parallel sides are called the legs of the trapezoid. If the legs of the trapezoid are congruent, then you have a special trapezoid that's called an isosceles trapezoid. So let's talk about some special properties or some special theorems if you have an isosceles trapezoid. So if a trapezoid is isosceles, then each pair of base angles is congruent. So again, for it to be an isosceles trapezoid, you'd have to have that the legs would be congruent, and we'd have to say that the base angles, like angle A, would have to be congruent to angle B, and we'd also have to have that the other pair of base angles, angle D, would have to be congruent to angle C. If a trapezoid has a pair of congruent base angles, then it is an isosceles trapezoid. So it kind of works both ways. So for example, if we have a pair of congruent base angles, like in this case, angle D and angle C are both congruent, then we can make the assumption that ABCD is an isosceles trapezoid. In Theorem 6.16, a trapezoid is isosceles if and only if the diagonals are congruent. So the ABCD is isosceles if and only if AC is congruent to BD. Now what we're going to use is we're going to use some of those properties that we just learned about isosceles trapezoids, and we're going to actually put them to use right now. So we know right now that WXYZ is an isosceles trapezoid. So now we're going to use that information to find some missing angle measurements. So we're going to find the measurement of angle X, the measurement of angle Y, and the measurement of angle Z. And we're given in the picture right now that the measurement of angle W is equal to 110 degrees. So based on what we've learned right now, and we know that this is an isosceles trapezoid, we know the base angles would have to be congruent. So we know that the measure of angle X would have to equal the measurement of angle W. So therefore, the measurement of angle X would have to also equal 110 degrees. The next thing that we can get out of this is based off of parallel lines. So angle W and angle Z, they're consecutive interior angles because of those parallel lines, or same side interior. You can almost think of this WZ as like the transversal. And because of that, we can say that they're supplementary. So if you would add up the measurement of angle W and the measurement of angle Z, they'd have to add up to 180 degrees. So we already know the measurement of angle W is equal to 110. So if we would subtract 110 from both sides, we get our answer for the measurement of angle Z. It's going to be 70. All right, and since we know that this is an isosceles trapezoid, we would also know that, again, the base angles would have to be congruent to one another. So the measurement of angle Y has to equal the measurement of angle Z. So this would have to also equal 70 degrees. Okay, we're also going to use what we know about properties of trapezoids to show by a coordinate proof that you actually would have a trapezoid as well. And we can do that by comparing some slopes. So I could use that by counting rise over run or by using slope formula to help me to do that. Now remember that by definition, a trapezoid only has to have one set of parallel sides. And remember, to do that by slope, that would mean that you would have to have two slopes that are exactly the same. So if I would start looking at the slope of point H and point K, I see I have 0, 6, and I have 4, 8. So if I started calculating the slope, I would do 8 minus 6, and I would do 4 minus 0. And if I started simplifying that, that gives me 2 over 4, which gives me a slope of 1/2. Okay, I'm also going to make the comparison at the line below and look at ij. So again, I'm looking at the ordered pairs of 3, 0 and 9, 3 right now. So if I started to try and calculate that slope, 3 minus 0 for the y values, and 9 minus 3 for my x values. So again, when I simplify that, 3 over 6, and that would simplify down to 1/2. So right now, I'm showing that I have equal slopes. So because I have equal slopes, I'm showing that HK and IJ are parallel. Okay, I'm going to try to keep going further, and I'm going to try to see if this is more than just a trapezoid. So I would try and look at HI, and I'm going to look at JK. So if I looked at HI, I'd be looking at 0, 6 and 3, 0. So I could do y sub 2 minus y sub 1 over x sub 2 minus x sub 1, and I would get 6 over negative 3, and I'd get a slope of negative 2. So I would have to think that kj or jk would be the same thing. So I'd be looking at 4, 8 and 9, 3. So again, y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So I'm going to go 3 minus 8 and 9 minus 4. And this time you can see I'm getting negative 5 over 5, which is going to give me negative 1. And you can tell just by looking at the picture that those slopes are not going to be the same. So the slope of HI and JK are not equal. So from that assumption and from this coordinate proof, we're basically saying that HI is not parallel to JK. So because of that, we can only make the assumption that this HIJK is only a trapezoid. And by definition, that is correct because we've only got one set of parallel sides. Just like we had midsegments and triangles, there's also what's called a midsegment of a trapezoid. A midsegment of a trapezoid is the segment that connects the midpoints of its legs. And you can see that we have segment AB that's cut into 2 equal parts, and segment CD that's also cut into 2 equal parts from this midsegment. And the midsegment theorem for trapezoids works as like this. The midsegment of a trapezoid is parallel to each base, and its length is 1/2 of the sum of the lengths of the bases. So MN is parallel to BC, and MN is also parallel to AD. And the other part of this theorem works that it would be half of BC and AD when you add those two lengths added together. All right, so let's take a look at an application using the mid-segment lengths of a trapezoid. So let's say you have a baker and he's making a cake like the one at the right. The top layer has a diameter of 8 inches and the bottom layer has a diameter of 20 inches. How big should the middle layer of the cake be? So if we know the top layer has to be 8 inches and we know the bottom layer has to be 20 inches, you can see that the shape is resembling a trapezoid. So we'd be using an application right now of the midsegment theorem for trapezoids. So we're trying to figure out the length of DG. So this would be 1/2 of the top layer plus the bottom layer. So half of 28 would be our answer. So that middle layer should be about 14 inches then. All right, let's take a look and see now at a checkpoint for you guys to see how you're doing with these trapezoids. All right, so for your first checkpoint right now, it says we need that ABCD is an isosceles trapezoid. We need to find the measurement of angle A, measurement of angle B, and the measurement of angle C. So it's important that you know it's an isosceles trapezoid. So now that you can use some of those special theorems that we learned about isosceles trapezoids. So take a moment right now and answer that question and fill your answers into Edpuzzle. All right, let's see if you got those right. The measurement of angle A has to be 35 degrees because base angles are congruent in an isosceles trapezoid. We also know in an isosceles trapezoid because we have two sets of parallel lines, or one set of parallel lines, that angle A and angle B would have to be supplementary angles because they would be same side interior. So we could do 180 minus the 35 that you found for angle A to get the angle measurement for the measurement of angle B to be 145 degrees. And then the measurement of angle C would also have to be 145 degrees because they are also congruent base angles. One of the last quadrilaterals that we're going to be talking about in our unit is the kite. A kite is a quadrilateral that has two pairs of consecutive congruent sides, but opposite sides are not congruent. And if we look at these two theorems down here at the bottom, it will elaborate a little bit further. If a quadrilateral is a kite, then its diagonals are perpendicular. So when we look at that particular quadrilateral that's a kite, we can say that segment AC is perpendicular to segment BD. Another special feature about a kite is that exactly one pair of opposite angles are congruent. So AC would be congruent to A would be congruent to C, or B would be congruent to D. So you get exactly one pair of opposite angles being congruent to one another. Okay, so in this application, we know that we are asked to find right now that the measurement of angle S and the measurement of angle U. We know this is a kite because we can see that we have two pairs of congruent sides, and we can see that they are not in exactly the same exact spots. That's what makes it a special feature being of a kite. Okay, so what we need to do next is we need to use that thing that we just learned, that a kite has exactly one pair of opposite angles that are congruent. And you can see right now that angle V and angle T are not congruent, so that must mean that angle S and angle U have to be congruent to one another. So we're going to say angle S is congruent to angle U, so that means that the measurement of angle S must equal the measurement of angle U. So let's use what we know about the sum of any type of quadrilateral adding up to 360 degrees, and then we're going to create an equation to help us to figure this out. So we know right now the measurement of angle V is 37 degrees. We know the measurement of angle T is 73 degrees, and we know we have two unknowns that are exactly equal to one another. So let's call the unknown X, And let's call the unknown the measurement of angle S, because we actually know the measurement of angle S equals the measurement of angle U. So we're going to say we have two of those. And we know that the total has to add up to 360 degrees because we have a quadrilateral. So if I add up 37 and 73, and then I add up my like terms, I can start combining this together to solve this equation. So I got 2x, and then I'm going to subtract these like terms from the 360. I'm going to divide both sides by 2, and I'm going to get my answer for x, which is 125. So I know right now the measurement of angle S equals 125 degrees, and so does the measurement of angle U. And if I added up 125, 125, 37, and 73, that would have to give me a total of 360 degrees. Another fact that I know about a kite is that the diagonals are perpendicular to one another. So in this particular problem, I am asked to find some side lengths. So I know that WXYZ is a kite, and I also know that diagonals are perpendicular. I need to know what the length of every single one of the side lengths are on the outside, knowing that they've given me some of the lengths on the inside. So I need to figure out what the length of XY is. I need to know what the length of YZ. I need to know the length of XW. And I also need to know the length of WZ. Now, one nice fact too I know about a kite is that those opposite sides from one another are also going to be congruent to one another. So really, I only need to do 2 problems to figure this out. And the hint in the problem is I can actually use Pythagorean theorem to help me out with this. So I'm actually going to figure out the length of XY right now. And because I know that these are perpendicular, I know that I have a right triangle to help me out with this. So I'm going to look at this right triangle right now to help me out. And I'm going to use the lengths of 12 and 12. And I know that I'm going to be trying to find the missing hypotenuse, which is xy. So I'm going to do 12 squared plus 12 squared, and that's going to get me the missing length of xy quantity squared. So 12 squared plus 12 squared, well, it's 144 plus 144, so that's going to give me 288. And remember, to solve for xy, you're going to be square rooting both sides. And let's leave our answer as a simplified root. So your answer is going to be 12 square roots of 2. So your answer for xy is 12 square roots of 2. Your answer for yz is also the same thing, 12 square roots of 2. And I'm just going to write that over here. So 12 square roots of 2, 12 square roots of 2. Okay, I'm going to do the same thing, except this time I'm going to be finding the lengths right now of the bottom, or the left-hand side, I guess, of the kite. So I'm going to be looking at the lengths of 12 and 20. I'm going to use this to find the length of XW, which would also be the same length as WZ. So I'm going to use 12 squared plus 20 squared, and that's going to give me XW quantity squared. Okay, so 12 squared is 144, and I know 20 squared is 400, so when I add that together, that's going to give me 544. Got to square root both sides and simplify that. So I'm going to give my answer as a simplified root, so 4, and then times the square root of 34 would be my most simplified precise answer. So 4 times the square root of 34. Okay, and I'm going to write that in up here so I can see my lengths. All right, as a last step for today, to make sure you understand, but need to know about kites, I want you guys right now to figure out what the measurement of angle X is and the measurement of angle Z and to type your answers into Edpuzzle. Okay, so remember, whenever you have a kite, only one pair of opposite angles are going to be congruent. So we can say safely that the measurement of angle X would have to be equal to the measurement of angle Z since the other pair of opposite angles are not congruent. So I can say that when we set this up, 139 plus 97 plus the two x's, our unknowns, will equal 360 degrees. When I simplify and solve that, our unknown will be 62. So that means the measurement of x equals the measurement of angle z, which is also going to be 62 degrees. So in today's lesson, you guys learned about some special properties about trapezoids and kites. So hopefully you guys can identify a special relationship either with a trapezoid or a kite and put that into Edpuzzle to kind of sum up what you've learned for today.